Okay, let's dive right into this explainer. We're going to explore how concepts like prototypes and tracer bullets are actually part of a much larger, totally universal decision-making framework. If you've ever felt completely overwhelmed by the sheer number of engineering techniques out there, or, if you've ever just struggled to figure out exactly how to start a complex project, well, you're absolutely in the right place. Today, we're going to move way past just memorizing engineering terminology. Instead, we're going to look at these concepts through the lens of a cozy, well-organized mental study room, treating them as essential items in a toolkit. As you'll see, mastering this framework doesn't just make you a better software engineer. No, it fundamentally changes how you approach learning, business, and even investing.
To really grasp this, I want you to picture a master carpenter building a house. They have this beautifully organized workbench right in front of them, right? And on that bench, there are dozens of tools. There's a heavy hammer, a sharp saw, a powerful drill. Now imagine walking up to that carpenter and asking, so, which of these tools is the absolute best? It's kind of an absurd question, right? I mean, you wouldn't use a hammer to cut a piece of wood in half, and you certainly wouldn't use a saw to drive a nail into a wall. No way.
The reality is none of them are the best overall. They simply exist to solve completely different problems. And you know what? Professional software engineering works the exact same way. When we talk about building a prototype, running a proof of concept, or developing a tracer bullet, we're not talking about competing techniques where one is magically superior to the others. The real skill of an engineer isn't just, reciting dictionary definitions of these terms. The true craft is recognizing precisely when each specific tool should be pulled from the workbench and put to use. Now here's your mental cheat sheet. We can actually map these specific software techniques directly to the exact types of uncertainty they're designed to resolve. Think about it. Every single engineering project starts with uncertainty, but the flavor of that uncertainty changes. If your main unknown is about people, like, hey, will users actually understand how to use this new interface, you reach for a prototype. If the uncertainty is purely technological, like, can this specific AI model actually perform the task we need it to do, you reach for a proof of concept. And if your uncertainty is about integration, asking, can every single part of this massive system actually communicate and work together smoothly, boom, that's when you reach for a tracer bullet. So, here's the absolute crucial point. Experienced engineers don't ask which technique they prefer. Instead, they ask, what specific unknown is stopping us from moving forward right now? The overall project hasn't changed at all, just the specific type of uncertainty we're facing at that exact moment. When you shift your mindset to match this, these software concepts transform into a highly reusable decision-making framework. You completely stop relying on habit, and you start actively choosing your tools based on the actual roadblock in front of you. Let's move on to the next section. From code to coffee shops, expanding the mindset. This brilliantly illustrates how a proof of concept applies universally. Whether you're testing a cutting-edge AI model or, say, a really fancy new espresso machine, you're just running a small experiment to resolve technological uncertainty. In the software world, you'd write a tiny script to see if the AI can do the math. In a coffee shop, you buy the machine, plug it in, and literally pull 50 shots of espresso just to see if the mechanics of the machine can consistently produce high-quality coffee. It's the exact same fundamental question of capability, just in a totally different setting. And we see the exact same parallel with tracer bullets. Here, the focus shifts entirely from testing one piece of technology to proving that the entire operational flow works smoothly from start to finish. In software, a tracer bullet connects the database to the server to the user interface. In our coffee shop example, the tracer bullet is a soft launch. It's testing if a customer can walk through the door, understand the menu, place their order, have that order communicated to the barista, get their drink, pay, and walk out without causing a massive bottleneck during a morning rush. The thinking is identical. Can all the individual pieces actually work together as a cohesive system? All right, let's zoom out a bit more with this next section, learning and investing. Say you're learning a new programming language. Instead of trying to read hundreds of pages of documentation, which, let's be honest, is exhausting, you can run a tracer bullet by completing one continuous workflow. So many people try to learn 5 technologies all at once, and they just get stuck in tutorial hell. But professional engineers take a completely different route. They build one complete end-to-end project. They study a little, write the code, debug the errors, run the program, and review the output. That simple workflow, that's a tracer bullet. Reality immediately jumps in to teach you what you actually understand and what you don't. Reality becomes your teacher, not your assumptions. Now, what's really fascinating is that experienced investors use this exact same logic. They don't just ask what to buy. They make a small prototype investment to gather evidence and understand platform risks before scaling up. Beginners in investing are often totally paralyzed by the uncertainty of the market, right? They're always asking what's the best investment, but the seasoned pro asks, what uncertainty am I trying to reduce right now? Before risking any serious capital, they might make one tiny investment just to observe the mechanics of the process, learn how the trading platform actually works, and gather some concrete evidence. Only when that operational uncertainty is reduced do they go ahead and increase their investment. I actually use this exact philosophy for this very explainer. I build one complete workflow to generate a tracer bullet so that reality and analytics can tell me what actually works. When creating a new series, I build one complete pipeline, from researching to drafting the master document, finalizing the narration script, generating the visuals, designing the thumbnail, uploading it, and finally checking the analytics. Once that single workflow exists, every new topic I tackle becomes another tracer bullet fired through the system. The system continuously improves based on real feedback. It's literally the engineering mindset in action. So, the really cool thing is that once you recognize this pattern, you start to realize that all of these famous methodologies are essentially teaching the exact same underlying engineering philosophy. Whether you call it the scientific method, a fast feedback loop, iterative development, or lean startup, the terminology changes, sure, but the core pattern remains remarkably similar. Learning the individual techniques is great, but the real magic happens when you step back and recognize the deeper structural framework that connects all of them together. And it all builds up to this, the ultimate master loop. You identify the unknown, design an experiment, collect the data, reduce your risk, and then make a confident decision on what to do next. This is it. This is the universal loop sketched right out in our mental notebook. No matter what field you're in, this is how you conquer complex systems. You don't guess. You pinpoint exactly what you don't know, you design a tiny, highly focused experiment, like a prototype, a proof of concept, or a tracer bullet, just to test that one unknown. You look at the evidence it produces, your uncertainty drops, and suddenly, the next step becomes completely obvious. This really highlights the ultimate shift from a beginner who builds just because they can to a professional who builds specifically to eliminate the biggest risks in a complex system. Look, it's so tempting to just start building the easy parts of a project because, well, it feels like progress. But a true systems thinker actively resists that urge. They don't build just to build, they build strategically. They look at the entire landscape of their project, their business, or their learning journey. They identify the single most critical piece of uncertainty that could derail the whole shebang, and they build specifically to neutralize that exact risk.
So, to master any complex system in your career or life, I want you to stop asking which tool you should use. Instead, leave yourself with this single, incredibly powerful question. What question am I trying to answer? Once you clarify the exact question you need answered, the right tool from your toolkit becomes completely obvious. The specific techniques you use today might be temporary, but this way of thinking, this structured approach to systematically reducing uncertainty, is a real game changer you can reuse for the rest of your life. So as you look at the challenges in front of you today, let me leave you with this. What is the biggest unknown blocking your progress right now, and what small experiment are you going to design to figure it out?